In this video, we want to revise an examination question of A and B. Let's begin by working on A. Consider the following simple linear regression model of this. Derive the ordinary least squares estimator of beta 1 and beta 2. Then we also turn to B after working with A. Let's just turn to the board. So from the question, we are given that yi is equal to beta naught plus beta 1 xi plus the error, like that. So we want to derive beta naught and beta 1. So to begin, we have to first of all make this one the subject. So we'll say error I is equal to, taking these guys to the other side, we'll have y minus beta naught minus beta 1 xi, like that. Once we have this, the next thing that we need to do is to sum up this error squared. So we'll say let L be summation of n I starting from 1 of the error I squared, like that. But now we know the error is just this thing. So we are going to say error is just that beta naught beta 1 xi squared, like that. So once we reach here, we need to decide which one are we starting with, beta naught or beta 1. Well, let's begin with beta naught, because it's very easy when you get beta naught, you get beta 1. But for others, they can start with any, then they do some tenuous at some point, and they'll be able to derive those parameters. This one and the same. But in this video, let's begin with beta naught. So at this point, because this error we are summing up, we want to minimize it. So we are going to differentiate it. That means we want it to be very small. We are trying to minimize it. So when we try to differentiate this, we'll use the chain law. Thus, we'll drop the power, which is a 2 here. Then we'll have summation of I starting from 1. Then y, just copying the things inside, as beta 1 xi squared. Then this power will reduce by 1. And because we are differentiating with respect to beta 1, so what we are going to do is we are going to differentiate this. And notice that it will be just a negative 1, like that. So the second thing that we need to do, because this one is simply the slope and stuff like that, so we can make it a 0. Then if we make it a 0, we will have something of this. Before we just write there, I just want to say if this one is a 0, then we can take this one to the other side, so that 2 becomes a negative, and this one becomes a positive, and 1 multiplied by everything in here is just everything that we got inside. Then this 2 negative will just divide. So we are going to say, just want to write the negative well there. So we are going to divide that, then there, to the 0, because we have a 0 here. So we'll just have this term left. I is equals to 1, then open bracket I, beta naught minus beta 1, xi, like that, is equal to 0, like that. So once we are here, the second thing is just to distribute the summation. So when distributing the summation, we will have, first of all, summation of ni is equal to 1 of this term here, the first term, then minus summation of n I is equals to 1 of beta naught, then summation of, because beta naught is a constant, we'll factorize it, then we'll have summation of n I is equals to 1 xi, like that. And this is equal to 0, like that. Then once you are here, you need to remember some mathematics so that we can simplify this favor. If you recall, when we have x bar, let's say x bar of y. So this we say is equal to summation of n I starting from 1, then yi over n. So notice that if we introduce a 1 here and cross and multiply, we will have summation of I just equal to n multiplied by x bar like that. This. So this is what we are going to employ here. And we need to remember this because it's very important in this working, and we use it uh, as we go. So here, we know that this term is just equal to n y bar like that minus this one. Beta naught is just a constant. So if we're summing up, for example, we say 2 plus 2 plus 2 all the way up to n. So notice that this is just the same as saying 2 multiplied by n. So this is the logic here. We're going to say it's just n multiplied by beta naught, like that. Then this will be minus. So we know that this term in the variable summation of that is just n beta 1 then x bar, like that. Then this is equal to 0. What we want is beta naught. So we can take this term to the other side. So we will remain with pi bar of n, then minus n beta 1 x bar is equal to n beta naught, like that. So here n is common, so we can factor it out. We will have that, then at the brackets there, and minus beta 1 x bar, like that. Then we will have n beta naught, like that. So this we divide by n because we just want beta naught. So this will cancel, that will cancel, that will cancel, that will cancel. Then beta naught is just equal to y bar minus beta 1 x bar, like that. So this is our beta naught. Let's go on and get the beta 1. It becomes very easy when we have beta naught to get beta 1. Let me show you the very easy way of getting that. So I'm just trying to clear this. Remember, we are summing the error, which is just like so. So we'll repeat that process, but this time around, we are doing it for beta 1. So that is squared. So let's just first of all replace that. So beta naught we had is here. It's just y bar minus beta 1 of xi. I mean, this must be x bar of x bar. Close the brackets, we have beta 1 xi squared, like that. So the second thing that we need to do, some would like to differentiate from here, but I recommend that you just take your time just to simplify your life. So what you do, right, for example, in this video, I just want to show you a very simple one. So first of all, let's just expand this. Wrap I, starting from 1, of yi minus, when we multiply there, it will be minus pi bar. Then negative multiplied by negative, it will be plus beta 1 x bar. Then we'll have minus beta 1 xi squared, like so. Then we'll have L is equal to, here again summation I starting from 1. Then from here, what we need to do is just to group the like terms. So we'll say yi minus y bar, though they are not like terms, but they really look very similar because they have yy. Hope you can see that. So let's go on and group these other guys. So from these other guys, we want to start with this one, the negative. So we'll say negative beta 1, actually it's common, so we factor it out. But if we say that is negative, notice that here, when we factor out, here the x bar will be a negative. And here, when we multiply by the negative xi, will be a positive. So we'll have a positive xi, a negative x bar, like that. That is, if we multiply this negative throughout the things that we have. So we want to start with the positive one, which is xi, then minus x bar, like that. Then we'll have this whole thing squared, like that. And at this point, I'd recommend that now you can take the derivative, showing that you are trying to minimize your error as much as possible. So this time around, you're differentiating with respect to beta 1. So this will be summation of n I is starting from 1. And when we differentiate, we drop the power. So here we're supposed to have a 2 there. So let me just write this one. Well, so we'll have, let's go to 2 like that. Then inside is just the same things that we have. Y bar like that, minus beta 1 xi minus x bar. This whole thing in the bracket, but the power will reduce by 1, so we'll just have that. Then the other thing is to differentiate beta 1. So notice that if we differentiate beta 1, we will just get a 1. Then 1 multiplied by this term here, it will be just that term. So here we are multiplying everything by xi minus x bar like that. So from here, we make this term 0. So this one, sorry, is supposed to carry a negative because here we will have a negative 1. Yeah. So we shouldn't forget that. So here we'll have a 0. Then this negative, which is here, we can just bring it to the 2. So let me just write things properly. So we'll have negative 2, summation of that. We'll have I like that, I bar minus, stopping the things inside. And this everything multiplied by this term, like that. So this is equal to 0. So when we divide a negative 2 there, a negative 2 there, a negative 2 will go, and there we will remain with a 0. The 0 is selfish. Whatever you divide with it, you just get a 0. Don't know why. Might be wondering. Anyway, so let's work from here. So this term here is multiplying everything. So we can just multiply that. So we will have summation n I starting from 1, then y I minus y bar. Then if we multiply by that, we will have xi minus x bar, like that. Then this one, notice that this term and that term are just the same. So what we're going to do here is we are just going to say this term will be just squared because they are the same. So we square it like that. It's in 2 in 1, yeah. So we shouldn't forget a 0. We have a 0 there. So what we want is a beta 1. So we are going to take it to the other side like that so that we just remain with this term here. So let's go on and do that. So I want to start with the term we have taken the other side so that it looks very well like that. So that this term will go there. There's nothing like changing the signs. We are just interchanging. So this will be just summation of n I is equals to 1, then yi minus y bar, then xi minus x bar, like that. Then dividing by this term throughout, this term will cancel. Then we'll divide it to the other side like this. That's x bar like that. Then this is squared. It's supposed to be squared even there. So this is our beta 1. So let me just wrap this because it says gone so that we can see clearly that this term is our beta 1, like that. So if you reach here, then you have shown that beta 1 is equal to that, then beta naught, the one we tried at first, just like that. So let's go on now and work on the second question, which is B. So question B now. Here, use sections of your answer in question A, here, the one we are just from solving, above to demonstrate the least squares normal equation imply that this error is equal to 0. That's the first one. Then the other one is xi multiplied by the error is equal to 0. So we are going to use the sections from our workings to solve this. Well, let's just turn to the board. We work on that. So the question says we should use just our sections of our workings, and the first one says we should show that summation of that AI is equal to 0. So if you recall, in our first working, we said AI, if we rate it to be the subject of the formula, it will be just that minus beta naught minus beta 1 minus beta 1 xi, like that. So we should uh, know that this is just our E. So if we remember in our first working, where we were getting the beta naught, so we differentiated, we had something of this. This question we just need to use our sections. So when we differentiated, we had something of this sort. So we had something of that when we said this is just equal to 0 for the 2 and the negative went. So we just remained with that. So if you notice, this term we have in here is just our A. So if we say, okay, we replace summation of n I starting from 1, A. So notice that A is just a 0. Wow, that's nice. It's not too complicated. So just showing this, you have done it. So let's go to the second one, the one where we have summation I starting from 1, then we have xi, then you have the e high is equal to 0. So from here, if we come here, when we are trying to get the beta 1 here, if you differentiate here, let me just go ahead, space. So if you differentiate here, notice that you will have that beta 1, let me just drop it 2, like so, I starting from 1 like that, then you have I, which is yi, beta naught minus beta 1 xi, then like that. So if you come to differentiate here, notice that you'll have negative of xi, and this negative can go to the other side. So you'll have negative 2 of this xi at the end. Then if this one is a 0, I mean this one. So if we divide a negative 2, notice that this term will go, and that will just remain with, this one here, which is the summation of that one like that. Then this is just a e, then multiplied by x, I, which is just equal to 0 like that. So this, and the one we found, that means we have shown. Well, I want to say that's it for this video. Please join me in the next one.